Ever get that feeling? You're walking through a city at night, neon signs buzzing, and you think, there's more to this than meets the eye.
Mm.
Well, today, that feeling is our roadmap. We're diving deep into the world of neon, not just the retro glow, but its cosmic birth, its surprising rarity, even how it's involved in tech that seems straight out of sci-fi.
I like it.
You picked some intriguing articles on neon and atomic structure, so get ready to see this familiar element in a whole new light.
What's captivating about neon is how it acts as a gateway to bigger concepts.
Okay.
Understanding its story means understanding the evolution of the periodic table, the life cycle of stars, and even the delicate balance of our solar system.
It's like that quote, the universe in a grain of sand. Except in this case, it's the universe in a glowing tube. And speaking of that glow, the story of neon's discovery is a classic case of scientific serendipity.
Absolutely. Picture this. It's 1898,
Right?
and scientists Ramsey and Travers are hot on the trail of undiscovered elements. They're using a method called fractional distillation,
Right?
essentially chilling air until it becomes liquid, then slowly warming it up to separate the gases based on their boiling points.
Like a high-stakes game of cosmic hide-and-seek, with elements as the players. They were expecting to find a new element lighter than argon.
And they were right on the money with that prediction. But what they got was even more remarkable. Imagine their surprise when, as the chilled air began to warm, they witnessed a burst of brilliant red light, the first glimpse of neon.
Travers himself described it as a blaze of crimson light, sight he could dwell upon and never forget. Talk about a light bulb moment, right? No pun intended.
More than just a captivating spectacle, this discovery plugged a crucial gap in the periodic table, further solidifying our understanding of the elements and their properties.
Which brings us, of course, to the neon signs that bathed cities in their vibrant glow for decades. It's hard to imagine a time when they weren't synonymous with urban nightlife and bold advertising.
That iconic reddish orange, that's pure neon energized by electricity. You see, when electricity courses through neon gas at a low pressure, it excites the neon atoms, causing their electrons to jump to higher energy levels. When those energized electrons settle back down, they release energy in the form of light, the captivating glow we associate with neon.
Here's where I had my wait, what moment while prepping for this deep dive. I always thought all those colorful signs were just different flavors of neon. But it turns out most of those vibrant pinks, blues, and greens we see, not actually neon at all.
Spot on. That's a common misconception. While that classic reddish orange is pure neon in action, most other colors and signs are achieved using different gases like argon, mercury vapor, or even phosphor coatings inside the glass tubes. Each gas, when excited, emits its own unique color.
So that bright blue neon sign might be argon putting on a convincing performance.
Exactly. It speaks to the ingenuity of the scientists and engineers who, even back in the early 20th century, were adept at manipulating the properties of different gases to create such a visually stunning array of colors.
And here's where our deep dive takes us from the bright lights of Earth to the vast cosmic canvas. You with me?
Absolutely.
Okay, good.
It's fascinating how an element so intertwined with human culture is actually far more abundant in the universe than it is on our planet.
Right. It's like neon is playing cosmic hide-and-seek. We see it lighting up our cities, but the universe is where it really lets loose. So why is neon, this cosmic party animal, such a rare guest here on Earth?
It all boils down to how neon is formed and its inherent need to, well, keep moving. Remember how we talked about neon being forged in stars?
Yeah.
Under immense pressure and heat, carbon atoms fuse, eventually creating neon. This happens towards the end of a star's life cycle, during a supernova when it explodes, scattering elements like neon across the galaxy.
So neon is born from the most dramatic events in the universe. No wonder it likes to make an entrance.
Exactly. But here's the catch. Neon is incredibly lightweight and stays a gas even at extremely low temperatures. Imagine trying to hold onto a fistful of air. It's just not going to happen.
So when our solar system was forming billions of years ago, the intense heat from the young sun acted like a giant hairdryer on those lighter elements.
Precisely. And neon, always up for an adventure, was among the first to be whisked away by the solar wind. Think of it like this. If you were holding a bunch of balloons and a strong gust of wind came along,
The balloons would be gone in a flash.
exactly. That's essentially what happened to a lot of the neon in the early solar system.
Wow.
It got swept away, ending up in the outer regions or lost to the vastness of space. The heavier elements, like those that make up our planet, were better at resisting the solar wind.
Makes sense. But it's incredible to think that something so common throughout the universe is relatively rare here on Earth. It's a great reminder of the mind-boggling scale and power of cosmic events, isn't it?
Absolutely. And there's even more to the story. Remember when we talked about the Galileo probe?
Uh-huh.
Well, when it plunged into Jupiter's atmosphere, it found something unexpected. Jupiter had far less neon than scientists anticipated.
Even Jupiter, the largest planet in our solar system, couldn't hold on to all its neon. That's wild.
It is. And it suggests that even these gas giants weren't immune to the effects of the early solar wind. This finding provided valuable clues about the formation of our solar system and the complex dance of elements within it.
Okay, so we've covered neon's cosmic origins, its great escape from Earth. Are you ready to get a little more technical? Because to understand neon's versatility, we need to talk isotopes.
Sure.
Okay.
Don't worry, I promise to make it painless. Remember how all atoms of an element have the same number of protons? That's their atomic number, like a fingerprint that identifies them. But they can have different numbers of neutrons. These variations are called isotopes.
Okay, so it's like having different versions of the same element, right? Like they all have the same basic personality, their atomic number, but the number of neutrons adds some individual flair.
A great way to put it. Now, neon has three main isotopes: neon 20, neon 21, and neon 22. Neon 20 is the most abundant and stable. It's the neon we typically think of.
The life of the party.
Exactly. Now, neon 21 is a bit more intriguing. Some of it is actually created right here on Earth when cosmic rays, those high-energy particles from space, collide with atoms in our atmosphere.
So even though neon likes to escape Earth, the cosmos finds a way to send some back.
Precisely. And finally, we have neon 22, another stable isotope. The fascinating thing about isotopes is that these tiny variations in neutrons can actually influence an element's properties.
Okay, so it's not just a numbers game on the periodic table. These isotopes actually behave differently.
Exactly. Think of it like this. Imagine three identical-looking balloons filled with slightly different amounts of helium. They might look the same, but one might float a bit higher or last a bit longer. Similarly, different isotopes of an element can have varying degrees of stability or even radioactivity, which opens up a whole world of applications.
That makes sense. But before we move on, how does all this tie back into neon's atomic structure? We briefly touched on full outer shells and stability.
Ah, yes. To really grasp neon's standoffishness when it comes to chemical reactions, we need to zoom in on its electrons. Imagine them arranged in shells around the nucleus, like layers of an onion.
I'm picturing those classic atomic diagrams we all saw in school, a nucleus in the center with electrons whizzing around it.
Precisely. Now, neon, in its stable state, has a full outer shell, 8 electrons in its outermost layer. And in the world of atoms, having a full outer shell is like having all your ducks in a row. It signifies stability and a reluctance to interact with other atoms. This is what makes neon and its fellow noble gases famously unreactive.
So neon is like that independent friend who's perfectly content with their own company. They're not looking to form any close bonds, chemically speaking at least. It's incredible to think that something as seemingly simple as a full electron shell can dictate an element's entire personality, so to speak.
It's a perfect example of how the universe operates on these elegant principles of balance and structure. But don't let that fool you into thinking neon is boring. It might be chemically aloof, content with its stable structure, but its applications are anything but dull. We've already touched on its star power in neon signs, but that's really just the tip of the iceberg.
Right. It's like neon spent a few decades as the life of the party, lighting up cities with its glow, and then decided to become a silent powerhouse, quietly working behind the scenes in all sorts of fascinating technologies.
Exactly. And this is where those unique properties we've been discussing come into play. For instance, remember how we talked about neon remaining a gas at incredibly low temperatures?
Colder than a winter night on Mars, if I recall correctly.
Precisely. That makes neon indispensable in the world of cryogenics, the science of achieving ultra-low temperatures. We're talking about freezing things to temperatures so low that biological processes grind to a halt, enabling us to preserve delicate samples like DNA or tissues. Even some of the most cutting-edge physics experiments, like those exploring superconductivity where electricity flows with zero resistance, rely on neon to reach those mind-bogglingly low temperatures.
It's like neon is the ultimate ice-cold multitasker of the element world. But it's not just about keeping things cold, right? I remember reading something about lasers.
You're right on the money. Neon is a key component in certain types of lasers, those beams of highly focused light used in everything, from barcode scanners at the grocery store to delicate laser eye surgery. And let's not forget about neon's role as a tracer in various scientific fields. Its presence, even in tiny amounts, can help researchers track the movement of air currents in the atmosphere or understand the intricate flow of fluids in complex systems.
Wow, talk about a hidden talent. It's like discovering that your quiet neighbor who loves crossword puzzles is also a world-class chef and a black belt in karate.
A very apt analogy. And it highlights something crucial for our listeners, those who, like you, are interested in quickly grasping the key takeaways. Even seemingly niche scientific topics like the properties of neon can have these ripple effects, impacting fields and technologies that touch our everyday lives in profound ways.
It's a great reminder that knowledge is interconnected, and sometimes the most unexpected discoveries come from delving deeper into those seemingly mundane details. But before we wrap up our neon journey, I think it's time for that signature, the deep dive move. A final thought to spark our listeners' curiosity and keep those mental gears turning.
I believe I know where you're going with this.
Imagine, if you will, a supernova. A star explodes in a dazzling cosmic display, scattering elements like neon across the vast expanse of space. Now, what if we could collect all that neon, bottle it up, so to speak, and use it to power something extraordinary here on Earth, something grand, something that embodies neon's dazzling legacy? Could we, hypothetically, capture enough neon from a supernova to illuminate the entirety of Times Square for an entire year?
What a captivating question. While the logistics might seem like something out of science fiction, it underscores the sheer scale of energy released in these cosmic events and the mind-boggling abundance of neon scattered throughout the universe. It's a thought-provoking way to connect the seemingly disparate worlds of stellar explosions and the familiar glow of neon lights right here on Earth.
And on that note, we'll leave you with a universe of possibilities to ponder. From its cosmic origins to its surprising role in our technological world, Neon's story reminds us that there's always more than meets the eye, even in the seemingly ordinary. Until next time, keep exploring, keep questioning, and keep diving deep into the wonders that surround us.